We are going to omit number 16 since we haven't learned bearings yet. We will learn that next semester. 17. The point given is on the terminal side of an angle in standard position. Find the cotangent, the secant, and the cosecant of the angle. So first we want to graph negative 3, 4. So we have a point right here. And if we draw a triangle and connect it to the x-axis, we know that the sides of the triangle would be negative 3, positive 4. Our hypotenuse would be 5 since we have a 3, 4, 5 triangle. And the angle theta that we'll use is the angle closest to the origin. So now we're ready. We can find the cotangent, the secant, and the cosecant. So the cotangent of theta, instead of opposite over adjacent, we would have adjacent over opposite, so negative 3 over 4. The secant of theta is the inverse of cosine, so instead of adjacent over hypotenuse, we would have hypotenuse over adjacent. And the cosecant of theta is the reciprocal of sine, so instead of opposite over hypotenuse, we have hypotenuse over opposite. Use the properties of inverse functions to evaluate the expression. So we want to find the tangent of the arcsine of 1/2. Well, since we're given arcsine, we're given two sides of the triangle. We're given that the opposite side is 1 and the hypotenuse is 2. And now we want to find the tangent of the angle theta. We can tell that this is a 30, 60, 90 triangle since the opposite side is 1 and the hypotenuse is 2. So the side we're missing is the square root of 3. So then the tangent would be 1 over root 3. And if we rationalized it, we would have root 3 over 3. Now we want to find the cosine of the arctangent of 1. So we are given two sides of the triangle. We're given the opposite side and the adjacent side. So the opposite side is 1, the adjacent side is 1. So the hypotenuse must be root 2, and we must be working with a 45-degree angle. So now if we find the cosine, we'll have 1 over the square root of 2, which is root 2 over 2. For number 20, we want to find the exact value of the cotangent of negative 390 degrees. So if we draw that out, we go all the way around the unit circle in the negative direction, and we have to keep going 30 degrees away. So we end up in the fourth quadrant, 30 degrees away from the x-axis. And we know that this would be the opposite side would be negative 1. The adjacent side would be root 3, and the hypotenuse is 2. So the cotangent, instead of opposite over adjacent, would be adjacent over opposite. So negative root 3 would be the answer. For number 21, we know that a 20-foot ladder makes a 62-degree angle with the ground as it leans against the wall. So here's the wall, here's my ladder, and we know that this angle is 62 degrees. How far up the wall does the ladder reach? So if our ladder is 20 feet, we want to know how far up the wall does the ladder reach. So we can call this side X. And we know that we'd want to use the sine since we are looking for the opposite side and we know the hypotenuse. So the sine of 62 degrees would equal x over 20. So the answer in calculator ready form would be 20 times the sine of 62 degrees. For the last one on this page, use the given trig value to evaluate the indicated expression. If sine t equals negative 1/4, find sine of t plus 6 pi. So if we think about what t plus 6 pi is, we know that if we have some angle somewhere, this angle would either have to be in the third or the fourth quadrant since it's negative. So we'll just draw one in the third quadrant. If we started at that angle and we added 6 pi to it, we have to think where we would end up. So if I started at the angle and I added 2 pi to it, I would end up in the same spot. If I added 2 pi to it again to make it 4 pi, I would end up in the same spot. And if I added 6 pi, or if I added 2 pi again to make it 6 pi, I would end up at the same exact angle. So since I ended up at the same exact angle, I would have the same exact answer as the sine of t, which is negative 1/4. For number 23, we want to find the cosine of the arcsine of 2 root x over 1 plus x. So we know that we can draw a triangle, and the opposite side of the triangle must be 2 root x, and the hypotenuse must be 1 plus x. So we're looking for the adjacent side since we want to find the cosine of the angle. So we can call this side b. So in order to find b, we can use Pythagorean theorem. So a squared plus b squared equals c squared. So we know that 2 root x squared plus b squared must equal 1 plus x squared, which would give us 4x plus b squared equals 1 plus 2x plus x squared. And if we get b squared alone, we end up with 1 minus 2x plus x squared. And if we try to square root that, it's kind of a weird answer, but if we realize that this is factorable, we end up with 1 minus x quantity squared. And if we square root that, we end up with b equaling 1 minus x. So now if we want to find the cosine of theta, we know that it would be 1 minus x over 1 plus x, which is choice B. For number 24, we want to let theta be an acute angle and use the given information to find the indicated value of the function. So we are given that the secant of theta equals root 41 over 5. If you want to, we can change that to the cosine of theta equals 5 over root 41. So we know that the adjacent side is 5, and the hypotenuse must be the square root of 41. And if we use the Pythagorean theorem, we would get that the opposite side is 41 minus 25. So we get 16, and if we square root that, we get 4. So the opposite side is 4. So now if we want to find the tangent of theta, we know that it is opposite over adjacent of theta, so it must be b, 4/5. And the last one on this page, give the exact value in radians. So we want to find the arcsine of negative 1. So we have to think what angle would give us a sine of negative 1. Well, if we start at 0, we have the coordinate 1, 0. The sine of that would be 0, so that is not the correct answer. If we move up to pi over 2, we have the coordinate 0, 1. The sine of that would be 1, so that's not the answer since we're looking for a negative 1. If we move down to negative pi over 2, because arcsine must be in between pi over 2 and negative pi over 2, we get the coordinate 0, -1. So the sine of negative pi over 2 is negative 1. So negative pi over 2 is our solution, since the sine of negative pi over 2 equals negative 1.